Road to Olympiad.
Welcome to RTO. Consider the following problems. Find the integer solution for x to the power of 5 minus x cubed minus x squared plus 1 is equal to y squared. Pause the video if you would like to give this problem a try, and when you are ready, keep watching to learn how to solve this. Well, first, let's take a look at some obvious solutions. When x is equal to 0, we get y squared is equal to 1. This gives us y is equal to plus or minus 1. Also, when x is equal to 1, we get y squared is equal to 0. This gives us y equal to 0. Similarly, when x is equal to negative 1, we also get y squared is equal to 0. That gives us y equal to 0. So what's about the solution other than this? Well, here we are going to claim that this will be the only solution. That is to say that there is no other integer solutions other than the one listed above. We are going to use proof by contradiction. Assume to the contrary that there is other integer solution with x not equal to negative 1, 0, and 1. Notice that we can factorize the given equation this way, and we'll come to x cubed minus 1 times x squared minus 1 is equal to y squared. This can be further factorized this way, which simplify to this final equation. Let's tidy up the screen. Now, from the assumption, x is not equal to 1. So we know that x minus 1 is non-zero. In this case, we can divide x minus 1 the whole thing square on both sides, and it will come out with this equation. This tells us that the product x plus 1 times x squared plus x plus 1 is a perfect square. Also, notice that the GCD of x plus 1 and x squared plus x plus 1 is equal to 1. For those who are unsure about this, let's have a quick proof on the claim.
Assume that the GCD is not equal to 1.
That is, we have the GCD is equal to some other integer d. This implies that x plus 1 is a multiple of d, say AD. And also x squared plus x plus 1 is another multiple of d, say BD. Multiplying x on the first equation, we have x squared plus x is equal to axd. Subtracting the two equations and simplifying, we get 1 is equal to d times b minus ax. Here, d is a factor of 1, which means d must be equal to 1. It's a contradiction. And thus, the GCD of x plus 1 and x squared plus x plus 1 must be equal to 1. Now let's come back to the proof. Since the GCD is equal to 1, in order for the product to be a perfect square, x plus 1 and x squared plus x plus 1 must be both perfect squares. However, for the case of x is less than or equal to negative 2, we have x plus 1 is negative, and x squared plus x plus 1, which is equal to x squared plus 2x plus 1 minus x, or x plus 1 squared minus x, is a positive number. So the product is negative, and thus it will never be a perfect square. Whereas for x is greater than or equal to 2, we have x squared plus x plus 1 is greater than x squared, but smaller than x squared plus 2x plus 1, which is the same as x plus 1 the whole thing square. This inequality tells us that x squared plus x plus 1 is a number between two consecutive perfect squares. So it cannot be a perfect square. A contradiction occurs as there is no other solution other than the one we listed earlier. Therefore, the only solution for this problem are x is equal to 0, y equal to plus or minus 1, and also x is equal to plus or minus 1, y equal to 0. And this marks the end of the solution. Post in the comment below if you have any thought on the video. If you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.